Okay, so there are a lot of other statistics on layer 3. Let me just pick one more, which is quality of service, which is we've seen it that it's a common tool in some networks to distinguish between, let's say, high priority and low priority traffic. What we have seen is whenever it's implemented, it's only 80% correct. There's a lot of traffic that is just in the wrong service class. And the Allegro can help you very easily to figure out the right service class. Giving you a small example is if we search for class EF, which is telephony, I can simply see what are the top IP addresses who have used class EF. And interestingly, in our office, we see, for example, our backup system has class EF. And well, when we implemented that feature, we asked, what is it? We just look at the connections. And what we've seen here is that the NTP request, let's enable quality of service and disable the TCP stuff. The NTP request, so getting the time, went out with EF, but came back with, of course, default from the internet. So we even did the lookup to maybe to Switzerland here, which is useless, of course. But the standard setting for Windows for Linux operating systems that NTP always gets class reader time. And there are so many embedded appliances doing traffic with specific classes. So we decided to have a module that you can easily look into all classes on layer 3, but it's also available on layer 2. When we come to layer 4, we again have a lot of statistics. You can see all connections. You can see, for example, which port is used, and on each port, which class is used, but also which IP address is used. So if you see, for example, in our case, port 222 SSH, I can immediately see which server uses most SSH. So, for example, we do a backup by SSH to a server. That is our top SSH connection. So if we see the counters, that should be, yes. We uploaded 375 gigabytes to that server, and to the external one, 5.7, for example. And again, here we can also see the layers. Much more interestingly, what we've seen is the TCP statistics. Why? TCP is a very, very good indicator if the network works good or not. And because you see round trip times, which means whenever a handshake goes out, how long takes it the server to respond? Whenever data is sent, how long takes it that the server acknowledges that data? Or I'm at the network point in the middle and I see a lot of TCP traffic coming twice at my site, which means, okay, after the Allegro on that path, it looks like packets are dropped because they have to be retransmitted. And all these things can be displayed. Last but not least, we display TCP zero window, which is a very simple effect. Whenever the client can send data faster than the server can process it, the window size will get smaller and smaller, so the open window to send data. And at some point, TCP will announce, the TCP stack will announce from the server side, don't send any more data, or from the client side, so it's both sides. Don't send any more data. I have to process the data. And whenever you see TCP zero window, you can be very sure that the network is not the issue because the data was transferred. And that's what we can see here. We can, for example, sort by who sent most TCP zero windows. And in our case, it's the backup system because our disk system is faster, pushing the backup of all files to our backup system and overloads it. If you, for example, now, wait, no, I don't want to see the connection. I want to see again TCP windows, the IP address. Here, let's zoom out, for example, to the last day. We can see here that at a few times there are a lot of TCP0 windows. If we zoom into that time frame, we can immediately see, okay, here at that time, we saw a lot of TCP0 windows, meaning the server was overloaded. But we again see that the response time also of the TCP stack grow already and was not in the time of microseconds, but more in the times of even milliseconds, which is very long for servers sitting next to each other. And that helps a lot to debug that, okay, the backup station is overloaded and it's not the network. So there's a lot more statistics here. Okay, last but not least, maybe very interesting is the layer 7 decoding, where we decode, well, a long list of protocols, but as I have to mention, we constantly develop new protocols, new decoders for the Allegro. So there will be always more debugging, more application stuff with the next releases. So let me pick two of this long list. Number one is the classic layer 7 protocols, where we decode protocols in real time. And we just display that very similar to the port statistics. So whenever a protocol is used, we can tell you, okay, who used, for example, Windows file sharing, SMB. And then we can, then you can see, oh, that client used at that time. So again, the question here is, if we just zoom into, let's say, yesterday noon to afternoon, I can say for that time, okay, who used at that time most? So and here, one of our laptops used most of the time transferred 66.4 megabytes as an upload of SMB traffic. So this gives you a very good overview over specific protocols. We have here a list of more than 200 protocols and basically implement a lot of protocols on request. Also very important here is the SSL module, because we decode the SSL handshake. And whenever we do that, we can say, oh, that was this SSL server, because this is announced unencrypted in the common name for most SSL servers. And that allows to decode and correlate IP addresses to the millions of available SSL servers. And we have, for a few SSL servers, we also have layer 7 patterns, so like Facebook, YouTube, Google, and so on. But a lot of the smaller ones, we immediately see here on even internal servers. We can see our ERP system, which is Vavision, our Confluence, and other services. We can see immediately what is the response time, what is the load of that specific SSL server. Also very important, of course, is the SIP statistic. We see SIP as, well, I know very few offices who have not gone to SIP, but almost all, let's say, enterprises have moved or will move to SIP or something similar. And we have a very, very detailed SIP module, which allows you, for example, to see all SIP calls. The principal idea of our SIP call is that even if you have millions of calls per day, and we have customers doing that, we present you all calls and allow to search for specific criteria here. So let me, for example, pick that call we did here on. Okay, that was 1 second call, so maybe it was terminated quite fast. So we can search maybe for some longer calls that happened in our network. So here we had a very, very long call. We can zoom to it, and then we can immediately see, okay, for that call, we had very constant packet rate. We had some packet drops, but it was very, very low rate. We had in one direction a little jitter. We had in one direction, well, the caller, in this case, the mobile number called to the office. We had in one direction some MOS degrade, but very little. And let me show that bigger. We can show you the audio level. The audio level is very interesting because you immediately see if the microphone level is used and if there's really data in the RTP. We've seen many issues with VoIP where SIP worked, where RTP worked, but the codec didn't work. And that was very easy to debug with this feature. Again, here we can, for example, extract the SIP RTP and do a WebShark preview where we just see the invite, the trying, and then the RTP traffic. And of course, well, if we need the full call, we can also extract that as a PCAP file. Let's see, it's a 2-hour call. How long it takes to extract? Well, there's a very low-end disk behind. Then we can open even that call with Wireshark. So let's run that in the background. So that's a very, very small overview of the Allegro. There are a lot of more features behind. So we can even measure the latency between two Allegros passively. For example, we have an overview implemented right now, which we call a global dashboard. If you have multiple Allegros, if you have multiple mirror ports or multiple lines you monitor, you can even use one Allegro to analyze multiple links at one time, which we have here, where you can switch then between these lines or easily between Allegros. So there's already a lot of features in it.